Okay, so this video is going to be about exponential functions, and so I'm going to start off by doing a specific example. So we have the function f of x equals 9 to the x. So let's find the values of each of these. So f of 0, remember that f of 0, whatever's inside the parentheses, we place the x with that number. So f of 0, that's going to be 9 to the power of 0, and 9 to the power of 0 is 1. So f of 0 is going to be 1. F of negative 1, that's 9 to the negative 1, and that's 1/9. Okay, f of 0.5, so we're going to take the x and replace it with 0.5. So this is going to be 9 to the 0.5. Remember, 9 to the 0.5, that's the same thing as the square root of 9. And the square root of 9 is equal to 3. Okay, so that's the value for each of those. Okay, why don't you press pause while you try to find the value of each of these. All right, for the first one, you should have gotten negative 18, because negative 2 times 3 squared. 3 squared is 9, so we get negative 2 times 9 is negative 18. For f of negative 2, we get negative 2 times 3 to the negative 2. 3 to the negative 2 is 1 over 3 squared. And so this is equal to negative 2 times 1/9, which is negative 2/9. Next, we get negative 2 times 3 to the power of 0. And 3 to the power of 0 is 1. So this is negative 2 times 1, or negative 2. And finally, f of negative 1, well, negative 2 times 3 to the power of negative 1 is negative 2 times 1/3, and that's equal to negative 2/3. All right, so in general, an exponential function is a function of this form here. So I have a number a, which is some real number that's not 0, and a number b that's a positive real number, but it's not equal to 1. Okay, so that's the requirement on our base b in exponential functions. So for example, an exponential function could be say y equals negative 8 times 2 to the x. That's an exponential function. Y equals 0.7 times 1/5 to the x. That's an exponential function. If I have y equals, say, 3 times negative 2 to the x, that is not an exponential function because the base can't be a negative number. If I have, say, y equals 5x plus 1, well, that's not an exponential function because the x is not in the exponent. Okay, so that's not an exponential function either. Y equals 2x. Well, that's not an exponential function because this x here would have to be in the exponent if it were an exponential function. Okay, so this one is not, and this one is. Okay, so that's what an exponential function will look like. Okay, now we're going to see what the graph of an exponential function can look like. All right, so for this exponential function here, why don't you press pause while you plot the points that correspond to these x values, and then we'll finish the rest of it off after that. Okay, so go ahead and press pause now. All right, so this is what you should have gotten for each of the values. So you get f of negative 1 is equal to 1/4, then f of 0 is 1/2, f of 1 is 1, f of 2 is 2, and f of 3 is 4. So this is what we get if we plot those points. All right, so now we're going to use the calculator to help us complete the graph. So here's how we will enter exponential functions. Okay, so we're going to go to y equals, and I'm going to clear anything that was already there. So 0.5 times 2 to the x. So I'm going to enter 0.5, and then parentheses, times, and the number 2, and parentheses. And this right here, that will get us to an exponent. So it's to the power of, so again, it's 0.5 times 2 to the power of x. And then I always like to look at the standard window first to see if I can see the graph. So the standard window is zoom, and then 6. All right, so here's what the graph looks like, so helping us connect the dots. So, So here, these dots here are connected in a nice curved fashion. So it's going to go up, 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 up like this. And then here, the y values are slowly getting smaller and smaller and smaller. So this graph looks like it crosses or looks like it touches the x-axis, but it's not actually ever going to touch the x-axis because I can't raise 2 to any power and get 0 for the answer. So we're going to fill in the graph by doing this. Okay, so it's not going to reach the x-axis, but it's going to get super, super close. And just for your information, that's called a horizontal asymptote. Okay, so this is what the graph of this exponential function looks like. And in general, exponential functions will look like some variation of this. All right, but we're only going to be getting them by graphing them on the calculator right now. All right, so here's an example of where we would see an exponential function. So if we have a particular amount invested in an account that has an annual interest rate of 4%, if it's compounded 4 times per year, that means that every 3 months it's going to be compounded. And so that means every 3 months, since we're doing it 4 times a year, we're going to take this and divide it by 4, so that's going to be 1%. So every 3 months we're going to apply 1% interest to the amount that's there. All right, so if that's what happens, then the balance in the account after t years is going to be given by this. So we want to find the amount after 5 years. So this 5 here, that's a t value. So we're going to plug it in for the t there. So we'll get 1,200, this is approximately, times 1.0406 to the power of 5. And this is how we have to enter that on our calculator. Okay, so I will enter 1,200 times 1.0406 to the power of 5. And so that's around $1,464.20. Okay, so that's an example of where you'd see an exponential function in real life. Okay, suppose I have a table of values. How can I tell if it represents an exponential function? Well, the first thing that I'm going to do is I'm going to go to the row that has the x's. And so we're starting at -1. So to get to the next x value, I'm just adding 1 unit. Okay, so this next x value is 1 unit away. And well, to get from 0 to 1, it's also 1 unit away. To get from 1 to 2, it's also 1 unit away. So if my starting value is some number, and then to get to each next value I add 1, then I can tell easily if I have an exponential function by looking at the next row. Okay? So what we're going to do is we're just going to worry about the ones that have your x values, whole numbers, in order like this. Okay, or negative integers, or positive integers, or 0 in order like this. Okay, so once we make sure that that's true, we're going to look at the bottom row. So to get from 1/3 to 1, we're going to multiply by 3. To get from 1 to 3, we multiply by 3 again. To get from 3 to 9, we multiply by 3 again. So if your first row, to get to each next value, we add 1, and if the bottom row, to get to each next value, we multiply by the same number, then it does represent an exponential function. Okay, so that's how we can tell if we have a table of values. If this were -1 and then we add 1, it gets to 0, but then if we had to add 2 to get to the next one, we couldn't easily tell from a table of values. Okay, so we can't always easily tell from a table of values whether or not it represents an exponential function, but in the case where each of these is just 1 unit apart, we can. Okay, and we just have to make sure that for the bottom row, we're multiplying by the same number to get each next one.